Okay, so the other day we talked about how you had the triangle proportionality theorem, which says if you have parallel lines inside a triangle that the sides are proportional. So we kind of extend that now, but when you have three or more sets of parallel lines cut by transversals, you set it up similarly. Okay, so when you have two transversals, so in this picture I have a transversal and a transversal. Remember, the transversal is the one that intersects at each line at a different spot. Okay, and with your three or more parallel lines, then it divides the transversals proportionally. So this portion and this portion are congruent to this portion, or this over this. Okay, so if you notice, if I were to extend this, I would just create a triangle. So really this is the triangle proportionality theorem. It just is extended so that I don't have to show all parts of the triangle, and we can look at more than one set of parallel lines. Okay? So if R is parallel to S, so this is R, this is S, and S is parallel to T, okay, and line L and M, so this is L, this is M, intersect R, S, and T, then if I take U, W over WY, that equals VX over XZ. So this over this is proportional to this over this. Okay? So if I have this picture right here, notice all three of these are parallel, so we're okay for the setup. Oh, I missed that arrow. Okay, so this over this is going to be proportional, and this over this is going to be proportional. Now we have a small problem, because this is the whole thing that we're talking about from here to here, and this is the whole thing that we're talking about from here to here. Okay, so if this is, it's an 8, not an S. If this is 20 and this is 8, then this has to be 12. Okay. If this is 21 and this whole thing is 15 plus 2x, what I can do is 15, I'll do it down here, 15 plus 2x, and I take away 21, and that's going to be this portion right here. Right? So I can simplify this and do 15 minus 21, which gives you a negative 6. So I have 2x minus 6. So now this part right here is 2x minus 6. So when I set up my proportion, I'm going to do 21 over the 2x minus 6 is going to be equal to the 12 over the 8. Okay. So I'm going to cross multiply to solve, so 21 times 8 equals 12 times 2x minus 6. Notice I put the 2x minus 6 in parentheses even though I didn't have parentheses up here. It's important that you put them so that I can distribute the 12 to both the 2x and the 6. So 21 times 8 gives you 168. And 12 times 2 is 24, and then x. And then 12 times 6 is 72. Okay, so to get this by itself, I have to add the 72 to the other side. So if I do 168 plus 72, I get 240. And that equals 24x. I'm kind of out of space, so I'm going to move up here. So I'm going to rewrite the line. So 240 equals 24x. So to undo multiplying by 24, I'm going to divide by 24 on both sides. So I get x is 10. Notice it just said solve for x. It didn't tell me to find a certain side length. It just said solve for x. So I'm done. Okay. On our next one, we're going to talk about bisectors, angle bisectors. We've come across angle bisectors a couple different times. The first time we were just talking about if I cut an angle in half, then I have these two parts equal. You can have them represented by expressions and solve. Okay. Well, then we came across it when we were talking about triangles, and we had medians and altitudes and perpendicular bisectors and angle bisectors. Okay. Now we're going to look at it in a triangle with our proportional sides. So if CD, so I have A, B, C. If CD bisects angle BCA. Then we're going to call this D, because that's what is bisecting it. Notice it's a ray. I just have an arrow over one side. Bisects BCA, then AD over DB is proportional to CA over CB. So the part that got cut with the part next to it, and the part that got cut with the part next to it. Okay? So, for example, if I want to find the missing side, given that this is an angle bisector, I know it's an angle bisector because I have these markings here. If I want this side, I'm going to set up 21 over 28, the side that got cut by the angle bisector with the one next to it, is going to equal the one that got cut with the one next to it. So I'm going to label it as X. It has a question mark, but I'm going to rename it as X. So now I cross multiply. So I get 21x equals 28 times 9. So 28 times 9 gives you 252 equals 21x. So I divide by 21 to undo this multiplying. So x is 12. Okay. Now, I could have also set up my proportion where I did 21 over 9 equals 28 over x. So I could have done 20 with the part and the part over the part next to it and the part next to it. Notice that we're using our equivalent proportions that we learned about a couple days ago, where I have top over top equals bottom over bottom. So 21 over 9 equals 28 over x. Notice when I cross multiply, I still get 21x equals 28 times 9. So either setup is okay. From the definition that we looked at, you're going to do this part over this part equals this part over this part. Okay? But either one is okay for the setup. Notice I used the secondary one over the original one from the definition. So on this one, let's start with the definition one. So this part over this part, but that means I need to find this part right here. Well, if the whole thing's 6 and this is 2, then this has to be 4. So I'm going to do 4 over 2 is going to be equal to, notice since I started with 4, I'm going to take the side that the 4 is touching. So I'm going to take the 6 over, and I'm going to call this x. So I get 4x equals 12. So I'm going to divide by 4 to get rid of multiplying by 4. So x is 3. Okay. One more example. This time we have an expression that we're looking at. So I'm going to take this part over this part. Well, I have to write this part because we have the whole thing. So if this whole thing is 4x minus 2, then this part is going to be 4x minus 2 minus that chunk, so minus 21. So this simplifies to 4x minus 23. So this part right here is 4x minus 23. So now I'm going to take the parts that were cut in half, or not half, but cut proportionally. So I'm going to take 21 over 4x minus 23, and that's going to be equal to the side that the 21 is touching, so 28, and the side that the 4x minus 3 is touching, which is 12. So I cross multiply, so 21 times by 12 has to equal 28 times 4x minus 23. Notice again that since this is an expression, that I put it in parentheses so I can distribute the 28 to both the 4x and the 23. Okay? So if I do 21 times 12, I get 252. Then I do 28 times by 4, which gives you 112x. And then 23 times 28, nope, 23 times 28, struggling with my calculator, it gives you 644, and since it's positive times negative, I get negative. So now, to get the x by itself, I have to get rid of subtracting 644. So I add 644. So if I add 252 to 644, I get 896, and that's going to equal 112x. So to undo this multiplying right here, I'm going to divide by 112. So if I divide by 112, I get, our x value is 8. Okay? Notice back at our instructions that it says find the missing side. Well, in both of these problems, the missing side was just your variable. Okay, but our missing side here, there's two that we could be talking about, so we're going to look at both of them. So I'm going to plug x in for 4x minus 2. So I'm going to do 4 times 8 minus 2, so I get 32 minus 2, which is 30. So this side right here is 30. Well, if this is 30 and this is 21, then this has to be 9. Now I could also do 4 times 8 minus 23, so 32 minus 23, which is 9. So I found the 9 in two different ways, one by plugging in x and then one by doing 30 minus the 21 gives me the 9. Okay? So that's what we have with our extended triangle proportionality with 2 or 3 or more parallel lines. And then with your angle bisector, it proportionally cuts the other side in relation to the sides that it touches. And there you have that part.